MIO. The webinar today will be presented by Ashely Song, who is a Senior Program Manager at Microsoft's Maps and Geospatial team. Ashley's currently working on navigation services as well as routing, depending on which part of the world you come from, and logistics APIs. Alex Christian, who is a Senior Software Engineer at Microsoft's Maps and Geospatial team, will co-present the webinar with Ashely. Alex's main area of focus at Microsoft is MIO, and he will be demoing some example scenarios for us. Just a bit of housekeeping, if you could please stay on mute until the end of the webinar. You'll be able to answer questions at any point. Just enter those into the chat box and we will endeavour to answer those by the end of the session. Over to you, Ashely. Thank you very much.
Thank you for the introduction. Yeah, hello everyone. You can hear me, right? So my name is Ashely Song, and I'm a Senior Program Manager at Microsoft Maps and Geospatial Group. So today, my colleague Alex and I will show you some of the new enhancements we have made to the Bing Maps Multi-Itinerary Optimization API. So the Bing Maps Multi-Itinerary Optimization API, aka the MIO API, was first launched at Microsoft Build in May 2019. You can check out my Build conference video recording about the MIO API for reference. In that video, I described the underlying mechanisms of the MIO API and used the restaurant inspection scenario of 2 food inspectors and 13 restaurant locations to demonstrate the functionalities of the MIO API. The recording is available at aka.ms/bingmaps-mio-video. Our colleague Eric Lindemann also gave a presentation about the MIO API at last year's Microsoft Ignite in November 2019. The recording can be watched at aka.ms/bingmaps-mio-ignite video. The MIO API has a variety of use cases, for example, online shopping deliveries, on-demand shuttles, home repairs and appraisals, waste collection services, and so on. For any businesses with a fleet of drivers or a team of personnel, they already spend a significant amount of time and effort to maximize the workforce efficiency by planning the itineraries and optimizing the routes. For example, if you have 20 home nurses who need to visit 100 patients, you need to decide which nurse should visit which patients. Traditionally, the manual dispatching and coordinating a group of agents to stop at multiple locations was very time-consuming, and it was difficult to get the optimal solution, especially when taking into account additional variables such as the traffic condition, the available time windows of the agent shift schedules, and also the time windows of the locations to be visited, as well as the priorities of different locations. The level of the complexity of the problem increases exponentially as the number of agents and locations go up. As we all know, when the COVID-19 outbreak spread around the world in the last few months, more individuals and families have begun to order food essentials, groceries, and some other purchases to be delivered to their home, which created unprecedented demands of grocery transportation and food deliveries. There have been a number of news reports about the impact of the COVID-19 on delivery services. For example, the popular online delivery services are seeing greater than ever orders, and the online shopping becomes more difficult because it was really hard to secure the delivery slots due to the demand. And also the customers are experiencing a lot of delays and longer than normal wait times for their deliveries. So effective multi-stop route planning for delivery drivers has become more important with this sudden increase in demand. So why multi-itinerary optimization API? The Bing Maps Multi-Itinerary Optimization API, the MIO API, is a REST service that automates the process of building the itineraries for multiple agents, for example, delivery drivers or repair technicians, while optimizing their routes among all the agents to save the total time, to save the total travel distance or travel time, and efficiently deliver the services to all the customers. The MIO API does the smart scheduling based on each agent's shift schedules and the availability time of the customers to be serviced, as well as consider the traffic prediction when planning the routes. This becomes very important when there are a lot of agents and a lot of customers locations to visit. The AI can handle multi-day routes, multiple agents, and multiple shifts of the agents. The API respects the service time window and the priority of each of the itinerary items, and the dwell time has to be spent at the locations. Historic traffic data can be used for predicting the traffic when calculating the optimized routes. We have also added some new features to the MIO API to handle more complicated scenarios involving the capacity of the vehicles, the load quantities to be picked up or dropped off at each itinerary locations, the pickup and drop off location sequencing dependency, because for some deliveries you have to pick up the load at some location before you do the delivery. And also the depot location, which can be visited multiple times by the same agent when reload is necessary. The currently the API supports 50 agents and 500 locations per API call, and each itinerary location can be defined using the address or latitude and longitude. The API takes both synchronous and asynchronous API requests. Well, larger optimization should be using the asynchronous requests. The MIO API is available in all the markets where Bing Maps has routing coverage, except for China, Japan, and Korea. To configure for each agent, we can define one or more shifts. Each shift is defined in a working hour window and as well as the start and end locations of that shift. Only during these hours, we will schedule itinerary items for the agent, and the capacity is an optional parameter for the vehicle assigned to the agent. For each itinerary item, we can configure a preferred time window for when the agent should visit, and the dwell time for how long the agent needs to spend at that location. All these constraints are taken into consideration when optimizing the itineraries to make sure that the agent arrive and leave within the preferred or defined time windows. So the new parameter we added recently include the quantity, which takes the numeric values, while a positive value denotes load quantity to be picked up, and a negative value denotes load quantity to be dropped off at the location. Drop off from is another new parameter, which defines the location that the agent needs to visit before visiting the current location. Depot can be true or false to signify if a location can be visited more than once in the itinerary. For example, the agent may have to return to the warehouse to pick up more load before they continue the routes to service more locations. Additionally, we also have parameters. For example, the type, it specifies whether to use the traffic data or not when optimizing the itinerary. Road network is used to denote whether to use the actual road network information or just the flying distance between the locations. And the cost value is to define whether the customer want to optimize the itineraries based on the total travel time or the distance. So in my last year's Microsoft Build video, I described the underlying mechanism of the MIO API and use the restaurant's inspection scenario to demonstrate how to define and send the MIO API requests and what the API response looks like. So you may check out the MIO API demo page to see more examples. You may also check out that MIO API demo page. The link is included below at the bottom of the slide. You can look at the demo page to see more example scenarios and also how the API handles optimization with different input parameters. So as I mentioned earlier, this actually a lot of people ask about this. For the locations in the API request, we can actually define the locations using both the coordinates, the latitude, the longitude, and the address. So you can define the address for example, for the itinerary items, say the address is whatever address you want to use. And also for the agent, you can specify the end location or the start location using the coordinates or the address. So let's look at a sample scenario together before I hand off the presentation to Alex for a more live demo. So a food delivery carrier named Sam needs to deliver food from restaurants to some customers. Let's assume that Sam has a thermal bag which can only carry up to 12 food trays. So this we will use the capacity parameter to define. Sam will need to pick up the food orders from some restaurants before he delivers them to the customers. So to define this sequencing constraints, we will use a drop-off from parameter. So let me show the sample request. So this snippet of the HTTP post request is in JSON format, and it shows how to define the start and end shift times for the agent, the start and end locations, and the capacity of the agents. It also shows how to define the locations, operating hours, dwell time, priorities, as well as the pickup and the drop-off quantity for each itinerary items. For example, Sam needs to pick up a quantity of 5 from pizza place. Sam also needs to pick up a quantity of 2 from Mexican food. And we use the drop-off from to signify that before delivering the food order to customer number 1, Sam needs to pick up the food from pizza place first. Once you have the post body ready, you can post a synchronous or asynchronous request with the agent shift and itinerary details defined in the post body. When there are more than 2 shifts or agents need to be scheduled, asynchronous requests need to be used. This example only has 1 agent and 1 shift, so either synchronous or asynchronous request is okay. You can use the HTTP post request URL with your own Bing Map API key. So here is the snippet of the JSON response returning information about the async or sync request. The response lists the route instruction for each agent, including the leaving from start location, traveling between the location, and visiting each location. The response also indicates that after leaving the first start location, from the start location, the first location for Sam to visit is a Mexican food restaurant, from where he needs to pick up a quantity of 2. And the second location for Sam to visit is customer 2, with the delivery of quantity 1 that was picked up from Mexican food earlier. Yeah, you can see that in the JSON, the drop-off from was returned by the API. The response also gives a summary of the route for each agent, including the start and end locations, start and end times, the total travel time for the agent, the total travel distance, as well as an ordered list of the waypoints between the start and end locations. And when the request is successful, a status code of 200 is returned. So here is a summary of the itinerary, the optimized itinerary for the agent based on the API response. And the itinerary can also be illustrated on the map. Just to be clear, the MIO API outputs the itinerary details in JSON or XML format, while the display of the agent, the display on the map is using our web control. It's something that you could use that comes with the directions and module to calculate the directions between the locations. And location 1 with the green halo is where the Sam starts his shift, and location 10 in the red is where he needs to end his shift. Note that the agent Sam first pick up 2 orders from Mexican food at location 2, and then makes his first Mexican food delivery to customer 2 at location 3. After that, he picks up all the orders from pizza place at location 4 and completes the route with 4 pizza place deliveries at different locations, as well as another Mexican food delivery for customer 4 at location 8. So here we list the current MIO API limits. So as I mentioned earlier, currently it supports up to 50 agents and 500 locations, and we are still working on further increase the limit, and Alex will talk about that in a little bit. And for different key type, we have different API limits, as well as the difference between the sync and async requests. Note that for both the sync request and async request, there's a limit of 2 for shift per agent for the trial and basic accounts, and the limits for the shift per agent is 5 for the enterprise accounts. So with that, I think I will hand over the presentation to Alex. So Alex, you can take the control over and start your demo. Thanks.
Thank you, Ashely. Hi, so my name is Alexander Christian, and I've been working on the MIO API from the beginning. And what I want to do today is talk a bit about a few details of MIO, and later on continue with some demo requests. Now, in the details sections, I want to touch a bit on runtime performance and the quality of results. All the data that I'm going to present is based on experiments that we did on data sets that were actually contained 1,400 requests, and with sizes varying from 10 locations all the way to 1,000 locations. We also have a research paper that's published with MIO, how it functions, and more of our findings. And there's a link in here to the original one that was accepted, and I presented at SIG Spatial last year. Now, the first thing is the results quality that I want to touch on. And first of all, MIO, it's web, the runtime performance. So I think I jumped one, the runtime performance, I jumped to one slide. First of all, MIO, it's a web API, and runtimes need to be small. And we also need to handle multiple concurrent requests. In order to do that, we leveraged Azure infrastructure that allows us to do auto scaling and use traffic managers to do load balancing. This ensures that we have a constant performance that scales with the service load. Now, when it comes to the actual problem that we solved, the route optimization is an NP-complete problem. So there isn't a defined algorithm that can be used and that can provide the correct answer in any polynomial time. So our solution is based on a heuristic approach, and that approach is called adaptive large neighborhood search. We describe it extensively in the paper, but in here I just want to show you how we compared it against the best known heuristic for solving traveling salesman problem, and that's Lin Kennigan Hoyland. Now, on the right side of the slide, I have a graph that plots the average runtime per item. So that means we get the runtime per whole requests, and we normalize that value for the number of items that we have in a request, so we can compare across the whole data set sizes. And what we see in here is that for small instances, linking again, it's blizzardly fast. It can be up to 70 times faster than our solution at MIO. But this actually changes as we scale the problem size, and we reach parity somewhere around 500 items. And after that, if we scale to all the way to 1,000, the dataset limit, MIO is actually 2 times faster than running again on that problem size. Now, the runtime for MIO is based on the problem size and the difficulty. Now, the difficulty, it's actually I'm referring to what kind of traveling salesman problem flavor we're dealing with, because if you remember from what Ashely was talking about, we support multiple constraints from time windows on the locations to capacity constraints, or for example, location ordering by defining pickup and drop-off constraints. We have a hard time limit of 10 minutes per request on the maximum problem size that we enable now. So that's 500 locations and 50 agents. With that said, the next thing that I want to talk about is the results quality. Now, the primary objective of MIO is to maximize the priority of the scheduled locations. Now, the priority is optional field in the request. That means that if you don't define any priority for the locations you want to get an itinerary, they will default to 1. And MIO will try to schedule as many locations as possible. In order to do that, the secondary objective it's to reduce the travel time or travel distance, and that's the cost value parameter that Ashely was referring to. Now, the datasets that we created all allowed for a complete schedule. That means that all the locations could be included into agent itineraries. So what we are analyzing now is the performance of the algorithm, the quality of results when it comes to minimizing the travel time, to reducing the actual time spent by each agent moving from one location to the other. And again, we normalize the results by the number of locations, so we can see the whole data sets. And what happens constantly is that MIO has better performance, and you can see that even from small data sets all the way to the largest ones, we have better results than using Lincoln again. It's one one thing that's actually interesting in here is also from the results, we can see how the economies of scale apply. Because as you can imagine, if you have the same area that you want to service, let's say that you have the Seattle area, and you create schedules for 10 or 50 locations. As you increase that size, then the average travel time between each location is going to decrease, because you're going to have a higher density of points in a single constrained area. So you can see that it drops from somewhere between 20 to 25 for 10 locations, all the way to somewhere between 10 to 15 locations as you increase the size. Now, another thing that I want to stress out is that MIO can handle traffic-dependent travel times. Now, that's a mouthful, but what it means is that going from point A to point B will take a different amount of time if you go in the morning when it's rush hour, let's say 9 a.m., or if you go somewhere during the night or in the weekend. And why is that important is, let's imagine that you are a service repairman, and you have some commitments that you made with fixed time window in which you need to get from, let's say, 1 to 2, and you create your whole schedule for today. So if you miss that appointment, that's gonna fare badly towards your customer and towards your business. And those service windows that you miss, we call them violations. Lincoln and Hoyman cannot take into consideration traffic-dependent travel times. And what we use in there in our calculations is the average travel time, the whole day for each road segment. So for each pair of source and destinations. And in the lower graph, we can see that the number of violations, the average violations per number of items, it's somewhere between 0.7 to 0.18. Now, this might seem small, but take into consideration that this would be percentages. So if you have, for example, 1,000 locations missing 180 of your schedules for a day, it's big. And with that said, I'm gonna jump to a demo in which I'm gonna show you how traffic impacts the result, how to use capacity and depots in requests, and how to leverage shifts and plan for multiple days. And last thing that I want to show is just a large sample request. So I'm gonna switch to our demo tool. Can you still see my screen?
Yes, I can see it.
Super. So what we have in here is a demo tool. I can just drop a sample request in this text box field here. This mimics the body of MIO request, and if I load it, then we have the maps control that can show me the locations. I can also see where are the start point and endpoints for each resource. I also have in here table with the resources that are defined, their shift start time, start location, and locations, and of course all the itinerary items with their individual constraints. This is a plane of the time window constraints. So I don't have any capacity constraints or any drop-off constraints in here. And what I'm gonna do is do request without traffic in here. And I'm also gonna do another request in here with the same locations, and I'm gonna do it with traffic, and then we can compare the results. So this shouldn't take long. We have applications and results already. So let me just try to maximize the. In here, I can see the agent shift. For each agent, I can see the shift and its start time, its shift end time, the location that it needs to visit. But what I want to showcase is the differences in the itinerary that we build. So we have, first of all, I want to stress something out. Each agent has a different start time in here. So agent 0 starts at 9:30. Then we have somebody starting at 7:30, 6:30, and 6 a.m. in the morning. Why I did that is to actually have them hit rush hour at different times. And we can see that first agent has a route somewhere in here. He's starting late, and because we don't take into consideration travel time, he's going to go all the way into downtown areas. It's actually not downtown area, but a very populated area in Seattle. Then we have another agent that's going towards Bellevue. Agent number 3, it's handling this area, and then another agent that's going on Mercer Island. Now, if we look at the traffic request, we can see that agent number 3, the one that starts the earliest, it's no longer going on Mercer Island, and he's going and doing a route here near the University District. So we can miss the rush hour. Then the agent that starts the latest at 9 a.m. and has the fewest points because he's going to hit traffic, is going to get the Mercer Island route. And we also have a few differences. Let me just try to maximize in here in how we handle this whole location near the University District. So in the previous one, the whole University District handled by one locations, and then 2 rogue points here near Morningside that were handled by the agent that was going towards Bellevue. But now things are completely different, and because of time constraints and how traffic influences the result, we need to split this whole area between 3 agents. And this is a very good example of how, in my point, traffic can impact results, and why MIO it's novel for being able to handle that. Now, with that said, I'm gonna jump to the second thing that I wanted to demo, and that is how to define capacity constraints. So again, I have a request here that I can load, and I have only one driver, one agent that I assume has a truck of capacity 16. Now, capacity here, it's something that's a very wide term and can be used to model different things. you can imagine, for example, that it can be the cubic volume of the truck. So if you have something that it's very big, you can just say that I'm moving furniture, and what I have, it's like 5 fridges, and each fridge or appliance has this volume, and I can fit X many cubic feet in a truck. Or if you are doing some pallets delivery, then the capacity of the agent can be the capacity of the truck in pallets. Or if the constraint that matters to you is the weight, then it can be the actual weight of each individual item, and then the weight capacity of the truck, car, or whatever is being used. Now, the corresponding value for the locations is the quantity. Now, the quantity can have either a positive or a negative value. Negative value means that you are dropping something off. So if we are talking about pallets, for example, in here, if you have a warehouse, then you can pick up to 100 pallets from that warehouse, and at customer 5, you need to drop 1 pallet, and your truck has a capacity of 16. If you want to do pickups from customers and drop off to a warehouse, you would have to change the values and have a negative value at the warehouse and a positive value of the customers. How do you define warehouses? Well, warehouses are defined by a flag that's called depot, and that's set to true. It's not necessary to have a depot. The best example is the one that Ashely provided with the pizza place and the Mexican food restaurant. You had no depot there. Depot means that this is just a special location where you can do multiple runs too. And I'm gonna do the request while I talk about this further on, so we can get the result, because it takes almost a minute. Why do you need this is because, for example, we have only one agent and he has a capacity of 16 for his truck. And if we look at the locations he needs to service, we have quantities that would exceed what he can do into one run. So you can imagine we're going to have multiple routes that go to customers, then it will return to the depot, it will service a few more customers, return to the depot to load, and so on. And here are the results. We can actually see that, let me try to maximize this again. He starts at the warehouse, he's gonna load up. He's gonna do a run to customer 7. Let me try to, yeah, that's customer 7 there. We also have point number 2 in here. It's the depot. It's really close to the starting location of the agent. And then he's gonna return and he's gonna load up again. If we look at how much this sums up, we can see that the next run, it's at full truck capacity. So we have 10 plus 6, so that's 16. And he's servicing in 5 clients. Then he's gonna return. So after he does this run in here, he's gonna return to the depot. Again gonna load up the truck with all the way to full to 16, and he's gonna do another run going to 11, 12, 13, 15, 16, 17, and all the way back returning. And this is how you can model, for example, somebody that has to do deliveries, and of course you can define multiple agents and different shifts for all of this. I have another example that does exactly this, and with capacity constraints. The novel thing in here is that I defined 2 depots. So let me just try to scroll here. We have depot 0 and we have depot 1. As you can see, both of them have the flag set to true. I'm gonna load the request and I'm also gonna run it. And then we have, you can see the depots here marked, and we also have agents starting at depots locations. We have an imbalance. So why I'm showing this is that we have an imbalanced number of agents. We have multiple agents starting at this depot. And as you can see, the area around it that would be serviced by it, it's quite small. Actually, it's not small, but we don't have a lot of customers. And then we have quite a few locations here, further away in San Diego and some around in this area of Los Angeles that we expect to be serviced from this depot. Sorry, I don't think I did. Yeah, I did a request. It takes a little bit longer. And what's going to happen is that one agent from this depot, it's just going to do a few locations around, it's going to service a few locations along the route to this depot, then load up and help the guys in this area. And again, the example that I have, it's with dropping off. And I defined different constraints on the vehicle capacities and different start times and end times for each agent. So in a few seconds, we should have the result. Let me.
And by the way, so I know some people comment that the font is really small. We will make some of the examples available on our API documentation page as examples, so you can check back later.
Let me see if I can, for example, try to fix that. I'm sorry, I can't see the chat now. Is this helpful? I try to zoom in.
Yeah, it looks larger than before, but I think you will need to maximize it when you show the map.
Yes,
I think that works better.
I'm maximizing it. So,
yeah, so is the result back?
Yes, it
okay.
is.
Yeah.
Can't you see the map?
Yeah. Okay.
That's right. So I'm just gonna maximize and try to zoom in on the map. So we have, for example, this agent. And you can see that he's going from this depot, servicing this location, stop 3, and this is agent 0, and then let me try to, and stop 4. Then he's picking up more items, and he's gonna go all the way to these locations from driving from depot 2 to returning here and then servicing a few more locations there. We also have agents going from depot number 2, going all the way to San Diego and servicing the areas in here. And, let me try to mount a bit so I can see in here. And in here we have the itinerary, and this is the interesting thing that I wanted to showcase, is that agent 0 starts really close, starts actually at depot number 0. He loads up, he services 2 locations. Then he goes to depot number 1, loads up, again services 1 location. From there, returns to depot number 1, services 2 more locations before ending up at his end shift location, that's depot 0. And we can see that the other agents do their routes from their individual depots. So you can have this behavior, and this might be helpful in some situations, especially if, let's say, for example, that somebody has to service a bigger area. You can decide on how to move resources from one depot to another. And actually, one thing that I did not showcase until now is that in our demo tool, we also have a nice route timeline that's showing based on the route summary when each agent is gonna hit each location. One thing that I want to show is how you can leverage, if I'm gonna do the request because I have it saved in here, how you can leverage shifts. So in my example, I have only one repairman, and you can think of it of somebody that's doing, for example, AC repair services. And I defined one shift for each day of the week for this week. And then I have multiple locations that would be clients, and they can be defined with service windows that span multiple days or in specific days. And the result looks something similar to this. And you can see that I have obtained for one agent a full week schedule, and the clients that he can visit and he can service during each day based on their preferences. So I can make this available, or the requests after this. So I'm just going to jump back to the future improvements. Actually, Ashely, can you do that? Because again, I have problems with my screen.
Yes, let me do that. Sure, let me do that. Okay.
So the things that we are working on and will be enabled in the future is, first of all, we do continuous development on this, and we increase the number of locations that you can service with MIO. Last year we had 102, this year we have 500 locations, and we plan to go to 5,000 very soon. We also want to do truck mode support on MIO, so that means instead of having a road network that's designed for cars, you can have truck restrictions because you have special turning radius or height restrictions on the bridges, and not all the routes are available for trucks. We also want to have multiple service windows per location. A good example would be in the one that I tried to showcase last time when you had clients. And instead of defining a time window that spans multiple days, to define multiple time windows for each day, because maybe one day he's available in the morning and another day he's available in the evening. Multiple dimensions for the quantity constraint. That would be, instead of having something that constraint that would be either the weight or the volume of the merchandise you're trying to deliver, why not define both? Because maybe you're gonna hit the limit on your truck on the weight first and not on the volume. So multiple constraints on that. And something that's being requested quite a lot is shift break support. So if somebody has a schedule that's defined for a full day, so a shift that starts at 9 a.m. and then let's say at 5 p.m., then maybe they have a break for lunch at 12 And that means that the schedule that we provide would need to stop somewhere in the middle and let the agent have its break and then continue from there. Thank you.
Yeah, thank you, Alex. And this concludes today's presentation about the MIO enhancement. For more information and full request body examples of the API, please visit our API documentation page and the Bing Maps blogs. And please visit the Microsoft.com/maps to learn more about the MIO API. And you can also find more information about our other APIs, for example, track routing API, distance metrics API, asynchronous API, and the snap to road API. To get started, you can create an evaluation account at no cost, and you can visit the Bing Maps Dev Center page at the bingmapsportal.com. Thank you so much for joining today's presentation, today's webinar. And for more information, please contact our Bing Maps distributor, Green Matter, for more information. Thank you.
Hi, Ashley. We have a couple of questions in the chat window. And the first of them is, are there any code examples, for example, on GitHub for people to leverage in their solutions?
Can people elaborate this ask? So what kind of code examples? And maybe Alex can answer the question.
I can answer the question. So we don't have code examples because this is a web API. So if you want to call it, you can just do normal HTTP requests. And then how you integrate that into a solution or a tool, it's up to who is developing the tool. We have sample JSON requests or XML requests in our documentation.
Excellent. Yes, and I think Ashley made that point in the beginning that this is a REST API, and all of the wonderful demos that you showed are using the V8 control to actually visualize the results of the REST call. Next, this is what you always get asked, Ashley. So how long till those new things come out? When will 5,000 locations and truck mode, when do you expect those to be available?
Thank you. That's an excellent questions. So Alex can answer the more exact timeline about the 5,000 locations. I think they will come in a couple of months, and as well as the track mode. So they are down the road, and just stay tuned, and we will make blog announcements as they become available. Right now, we have got very promising positive results based on our experiment for increasing the locations and the track mode.
Great. Now we've got another couple of questions. How does the API request correspond to billable transactions?
Yeah, that's an excellent question. So currently, the billable transactions is calculated based on the number of agents times the number of locations in your request. So for example, if you have 10 agents and 10 agents at 100 locations, so that will translate into 10 times 100, which is 1,000 transactions.
Great. And yeah. Another question is, how does the priority parameter work in the MIO request?
Thank you. So the priority, so it's a numeric value, so you can define from 1 to 99. And I think the larger number, the higher the priority. So if you want something to be, make sure that you want to be visited, you can set it as the highest value. And yeah.
I think that's all the questions that we have in the chat window.
Cool. Yeah, and I also want to have a quick comment on that billable transactions. So actually, if you consider, like you think between the distance metrics API and the MIO API actually will save you a lot of transactions because we do all the optimization already at the back end. So if you consider like 100 locations alone, like 100 locations pairs, that would be like almost 10,000 10,000 cells. Of course, we do the calculation to turn it into around 2,500 transactions for this metrics API. But but for the MIO API with 10 agents and 100 location, it's only like
so
10,000.
Ashely, there's a great question for you as you are the routing PM. When would a person choose distance matrix over MIO, or when would they choose MIO over distance matrix?
I think it's based on their use scenario. If they want to do the optimization and among multiple agents, MIO will be the perfect API or service for them to call. And because we already this matrix is actually the underlying mechanism we use as part of MIO. And with MIO, we also do the optimization. We have some advanced optimization algorithms. And so we handle that behind MIO. For distance metrics, I think some people may use it for some other use cases if they want to understand all the pairwise distance and travel time between the locations.
Yeah, I think I saw the scenarios that I saw that that sort of delineated it for me is we have one customer that is deciding their employees' best routes in order to get to work and from work every day. And as that's not really a delivery schedule, distance matrix did that very well. When you actually have to add the agents and you're going to multiple locations, MIO really is designed for that, to set that goal.
Yes, I think you hit the points. And because MIO can handle the different available time windows of the locations to be visited and also consider the different time schedule per agent. So there are more constraints that MIO can handle on top of the distance metrics.
So in the follow-up to how does the priority parameter work, you've got the question is how does the capacity priority work?
Sorry, there was some noise. So how was what?
How does the capacity parameter work?
Oh, so you define the capacity for each agent. So the agent is sometimes related to the vehicle, right? So the vehicle may have capacity constraints in terms of weight, height, or pallets or volume. So in part of that, you can use the quantity for each itinerary location. So the quantity is the amount that you want to deliver or pick up from a location, from an itinerary item. So they go in pairs. So say you have a capacity for an agent of 10, and the first location or some of the locations in the itinerary list will have a quantity of 1, 2, 3, things like that. And you use that number in quantity to define whether things need to be picked up or dropped off. And for more information, I think the API documentation has examples and around these. That would be a great place to go.
Yeah, I've given the documentation link in the window, and it's also in your presentation, so that's great. Now, Alex has jumped in and answered the question about the demo seeming quite slow. It's really a factor of how complex the calculation is going to be. So the more agents you have and the more locations you have, the longer the request will take, because I mean, that big distance matrix calculation is going on in the background, along with a bunch of other good stuff on top to do more optimization per agent and deal with those windows. There's a question: are there plans to expose this API for us to play with? And Ashely, I think that was your last note: is that anybody can sign up for a free account at our website at the Bing Maps portal, and that gives you 125,000 transactions for free per year. Now, so Adam, go ahead and play. Give it a try. Thank you, Ashely. And
Thank
thank you
you.
everybody for attending.